Have you heard about robots that can multitask, self-learn, and at the same time teach other robots? Yeah, Google's Deepmind has come up with such a revolutionary technology. Artificial intelligence has taken the world by storm, and one of the most significant contributors to the progression has been Google's Deepmind. It's taken self-learning to the next stage, and let's see how this is made possible. Established in 2010, Deepmind is an AI research lab that has made groundbreaking strides within the self-learning field, known as reinforcement learning. By harnessing the power of neural networks, big data, and advanced algorithms, Deepmind has pushed the boundaries of what AI can accomplish. Google's Deepmind's contributions have raised the field of self-learning to a new level. Let's try to understand what self-learning or reinforcement learning is all about. It's an AI training method where an agent learns to make decisions by interacting with its environment. Unlike supervised learning, where an AI model is trained or labeled data, or unsupervised learning, where the model finds patterns in unlabeled data, reinforcement learning focuses on maximizing cumulative rewards throughout trial and error. Deepmind's work in this area has been nothing short of revolutionary. Now, let's look into the Deepmind's biggest achievement, which came in 2013 when they developed a model called DeepQ Network, DQN. This model was the first to combine deep learning with reinforcement learning, enabling AI agents to learn and excel at classic video games like Atari 2600. Deep reinforcement learning, DRL, is a type of machine learning that permits AI framework to memorize to act ideally in an environment by trial and error. DRL systems are trained on a dataset of experiences, which are sequences of actions and rewards. The framework learns to relate certain actions with certain rewards, and over time, it becomes better at taking actions that lead to a desired result. Deepmind is a research company that has been at the cutting edge of DRL research. In 2016, Deepmind's AlphaGo program defeated a world-winning Go player, which was a breakthrough within the field of artificial intelligence. AlphaGo used profound learning and reinforcement learning to memorize to play Go at a superhuman level. DQN's ability to outperform human players in these games demonstrated the potential of deep reinforcement learning. Since that point, Deepmind has created several other DRL frameworks that have accomplished noteworthy results in a variety of domains, counting Atari game Geldis. Deepmind's DQN, DeepQ Network, calculation was able to memorize to play Atari diversions at a superhuman level. Protein folding. Deepmind's AlphaFord program was able to foresee the structure of proteins with phenomenal precision. Robotics. Deepmind mu0 program was able to memorize to play a variety of Atari games, indeed even though it was prepared on a single game. In 2016, Deepmind's AlphaGo made history by defeating the world winner Go player Li Sedol in a 5-game match. Go, an ancient Chinese board game, is known for its unimaginable complexity, with more possible board positions than there are atoms in the universe. AlphaGo's triumph checked a noteworthy turning point in AI, illustrating how self-learning algorithms can handle immensely complex issues. AlphaGo's triumph over human champions has had several implications for the field of artificial intelligence. AlphaGo's victory has moreover raised several moral concerns. A few individuals have contended that AI frameworks that can overcome human champions seem to pose a risk to humankind. Others have contended that AI frameworks ought not to be utilized to play games that people traditionally play, as this might lead to the erosion of human culture. Despite these concerns, AlphaGo's triumph over human champion could be a breakthrough in the improvement of artificial intelligence. It's appeared that AI framework can presently compete with humans at the most noteworthy levels of a complex game. This can be a significant achievement, and it's proposed that AI framework have the potential to outperform human capabilities in several other areas as well. The world is becoming more and more accustomed to the shifting technological tides. Robotics is not far behind artificial intelligence in terms of advancements across industries. Robotics has recently gained a new dimension thanks to Google's Deepmind. The most recent invention, the Robocat, is capable of carrying out a variety of duties using different robotic limbs. Since Robocat has the unique ability to tackle and adjust to a variety of tasks employing numerous robot types in real-world circumstances, it can be categorized as a new league of robotics. According to Google Deepmind, this has never been done in robotics before. The majority of robots, according to Deepmind's official site, are designed to carry out particular jobs. However, as AIs develop, robots might be able to handle more duties. It claimed that because real-world training data collection takes so long, general-purpose robot advancements is going far more slowly than it should. Robocat is a foundation agent for robotic manipulation. As such, it can perform many tasks with multiple robot types, and it can adapt quickly to previously unseen types of robots and skills. We can communicate a task we want Robocat to perform on any robot by showing it a desired configuration of objects to one of the cameras. This becomes the agent's goal, Google said in a demonstration video. So what is a Robocat? Robocat is a self-improving robotic AI agent, according to Google's Deepmind. It gains proficiency in a variety of tasks across numerous arms before producing fresh training data on its own to advance. Researchers have previously looked towards developing robots with the real-world abilities of a helper robot and the capacity to learn to multitask at scale and comprehend vast language models. Robocat is the first agent to carry out, adapt to, and do the same across several real robots, according to Google's Deepmind. The company asserts that compared to other cutting-edge models, Robocat learns a great deal more quickly. Due to its extensive use of a wide dataset, Robocat can learn a new task with as few as 100 demonstrations. This, according to Google's Deepmind, will aid in expediting robotics development because it almost eliminates the need for human assistance during training. The business views it as a development to the design of all-purpose robots. How does Robocat learn and improve itself? Robocat learns with the help of Gatto. Gatto is a multimodal model developed by Google's Deepmind that can process words, visuals, and actions in both virtual and real worlds. Robocat is based on Gatto. The company asserted that it was added as a sizable training dataset, action sequences, and photos of several robot arms completing hundreds of tasks to Gatto's architecture. The business said that following this circle, it put Robocat through a cycle of self-improvement training with a variety of unknown jobs. There were 5 processes involved in learning new duties. The company said in its official post, the combination of all this training means the latest Robocat is based on a dataset of millions of trajectories from both real and simulated robotic arms, including self-generated data. We use 4 different types of robots and many robotic arms to collect visions-based data representing the tasks Robocat would be trained to perform. Robocat is essentially an agent that has been training on video clips of hundreds of activities being performed and is a visual goal condition decision transformer. The information is acquired from a broad range of actual robot arm models in computer-simulated surroundings. The scientists used a sizable data set of photographs and movements of various robot arms performing hundreds of other tasks to train Gatto. After finishing the initial training, researchers put Robocat through a self-improvement training cycle with a fresh set of challenges. There were 5 steps to learning each new skill. The first step is to obtain 100 through 1,000 examples of new tasks of robots being demonstrated using a human-controlled robotic arm. For the new task arm, create a spin-off agent that is a finely tuned version of Robocat. The repurposed agent will train for 10,000 repetitions on this extra task arm on average. Add the sample data and fresh data you produce to Robocat's database. The new dataset should be used to retrain Robocat. The fact that this agent keeps learning and evolving with each new assignment is perhaps the most significant feature. Robocat's success rate more than doubled once it learned more tasks, according to Google's Deepmind. Robocat's versatility, adaptability, and multimodal skills have the potential to provide significant advantages for the robotics industry. Robocat is truly inspiring, with its ability to keep learning and continue evolving, which should be the motto of every human being. For sure, we can say that Google's Deepmind is pushing the limits of self-learning. Did you find Robocat impressive? Share your thoughts below. Thanks for watching.